Well, I've spent most of my time in writing books talking about the 7 deadly disruptors of, among other things, our microbiome. We're supposed to have 100 trillion different bacteria living in us, living in our mouth, living in our gut. And there are probably 10,000 different species of these bacteria. This is supposed to be a tropical rainforest. It's supposed to be this diverse ecosystem. We didn't even know these guys existed until the Human Microbiome Project was finished in 2017. We didn't know they were there, number one. Number two, we didn't know what these guys actually did. We now know that they make all these messages that make all our body systems, including our hormonal systems, work properly. The other thing we had no idea, I'm old enough to remember when broad-spectrum antibiotics were introduced in the mid-1970s when I was in medical school. They were miraculous because before then, if somebody had an infection, let's say they had pneumonia, well, we'd have to culture a bacteria on a petri dish, hope it would grow, and then we'd have to test it against certain antibiotics to find out which antibiotic would kill that particular bacteria. When broad-spectrum antibiotics came out, we didn't have to figure out what the bug was. We didn't have to figure out the antibiotic was. We basically got a shotgun out and blasted every last living bacteria to smithereens. And that was great. It was miraculous. It saved a lot of lives. What we didn't know is that these broad-spectrum antibiotics, solved the infectious problem, but it killed off this tropical rainforest within us. We had no idea, number one, that they were there. Number two, that we would kill them too. We should have realized. And number three, at the same time, researchers figured out that if you gave animals antibiotics, they would grow faster and put on much more fat than if you didn't give them antibiotics. So it became a routine part of agriculture to give antibiotics to chickens, beef, pork, whatever, to make them grow faster and fatter. And we had no idea that those antibiotics would be incorporated into their flesh, and we, eating their flesh, would every day be eating antibiotics that would kill off our microbiome. That's just actually one example that we just didn't know. 70% of all the antibiotics produced in this country are fed to animals right now. And we eat those animals. We can say, oh, well, we don't want to take broad-spectrum antibiotics. And quite frankly, we still take much too many. But more importantly, we're getting it in all the foods we eat. And add to the fact that simultaneous with all this, Roundup, glyphosate, was introduced as a weed killer 50 years ago. And most people don't know that Roundup was actually patented as an antibiotic. It wasn't patented as a weed killer. Most people to this day still don't know that Roundup is not primarily sprayed on genetically modified crops. It's sprayed on conventional crops to desiccate the plant, to kill the plant, because quite frankly, it's easier harvesting a crop when the plant is dead because it doesn't have any water and it's much more efficient. What we didn't know is that glyphosate is really good at killing off our gut microbiome. And it's sprayed on conventional wheat, conventional oats, conventional rice, soybeans, corn. You choose the crop and it's sprayed on it. So we've just done an incredible number on destroying probably the most important symbiotic organ within us that up until a few years ago, we didn't even know existed. And we're paying the price. So getting back to the original question, these organisms, number one, evolved through millions and millions of years to educate our immune system about what our immune system should be worried about and not worried about. These organisms evolved to, believe it or not, eat and protect us from plant compounds that might wish us harm. Believe it or not, there are bacteria that eat gluten. There are bacteria that eat oxalates. They're gone. Most people killed them off. No wonder so many people have issues with things that traditional societies don't have issues with because they've got an intact microbiome. We now know that there's a microbiome that makes hormones, that modulates hormones, that modulates estrogen, that modulates progesterone, that even modulates testosterone. And those guys are gone. or they've been altered. For instance, many women are shocked who are postmenopausal. They're still having hot flashes. Lo and behold, we can watch them make or not make estrogen, not from their ovaries, but from their gut microbiome. They're shocked that they're 10 years postmenopause and they make estrogen. They go, oh, no, that's impossible. I don't make estrogen. Well, yes, you do. Well, where's it coming from? My ovaries died a long time ago. Well, it's coming from, your fat cells, your microbiome. No wonder you've gotten into this problem, or at least that's contributing to it. Interestingly enough, we know that hormones influence the microbiome and the microbiome influences hormones. But what's fascinating is there's an obesogenic microbiome and there's a lean microbiome. This was actually discovered a number of years ago in animal studies where mice and rats are great because mice and rats actually like to eat feces. That's their thing. Some dog owners may have a dog that enjoys eating feces. So it's actually not unusual. Interestingly enough, you can take fat rats who have been bred to be fat and house them with skinny rats, and the skinny rats will become fat by eating the feces of the fat rat. You can take human feces, the humans are fat, and feed them to skinny rats, and the skinny rats will become fat by eating the human feces. How does that happen? Well, in two ways. Number one, we know that there are bacteria that are very efficient at extracting calories from the food we eat and then literally feeding it to us. In other words, they make the calories more absorbable. On the contrary, there are lean bacteria that actually keep all those extra calories for themselves to make more of themselves. And the beauty of that is they're going, gimme, I'm going to eat it. I'm going to make more of myself and we'll just poop out all those extra calories. Now, there's a third thing we've learned, and that is there's a control of our eating behavior by bacteria. And these are compounds. These are chemical signals. We call them postbiotics. I like people to think of them as text messages that bacteria can make that go up to the brain and say, hey, I'm hungry, but I'm hungry for specific things. I'm hungry for simple sugars, for simple carbohydrates, and I'm hungry for fats, particularly saturated fats. Our brain says, hey, we're getting this signal from the gut that we should be looking for these sorts of foods. If we eat those certain sorts of foods, unfortunately, the gut bacteria say, yeah, that's exactly what I'm looking for. Send some more. On the other hand, there's a theory that I like and I've written about called the gut-centric theory of hunger, that if you've got good bacteria, if you've got lean bacteria, those bacteria send messages to the brain that if you give them what they want, and quite simply, that's prebiotic fiber, soluble fiber, that they go, yeah, that's exactly what we wanted to eat. We're full. You don't have to go looking for any more food. And this has actually been proven in humans. In China, they took volunteers and put them on a 2-week water fast. One group, all they got was water. The other group got 100 calories a day of prebiotic fiber. Now, what that means is we don't digest prebiotic fiber. We can't absorb it. We can't turn it into carbohydrates. We can't get to it. But the gut bacteria, that's their favorite food. The folks who just had water were really hungry. The folks who got just 100 calories of prebiotic fiber, and again, they couldn't absorb it, they had no hunger, which literally proves that, yeah, these text messages were coming out of the gut from the gut microbiome saying, hey, we're in great shape. Our needs are met. You're fine. You don't have to go find anything else.